that was loud noise. Why do you use Xamarin? To share code, right? To share code between your iOS and your Android apps and maybe your Windows apps. But just using Xamarin doesn't necessarily mean that you're going to share as much code as you could. My name is Tess, and this is Peter.
I'm Peter, yes.
And we're from Developer Experience in Sweden. And a couple of months back, we were approached by this company called Live Arena. And what Live Arena does is it helps people or companies, or in this case, the best hockey team in Sweden, Leksand.
Go Leksand.
Broadcast themselves. So they give them the equipment and the platform to record videos and live stream and do all that. So in the case of Leksand, what they do is they record all their practices, and they record like player interviews and things like that. So me and my husband can sit there and be super fans. And they wanted to go from just being on the web to going to the mobile space. So their consultants came in and started doing iOS and Android apps, native iOS and Android apps in Objective-C and Java. But then quickly figured out that they were not sharing any code at all. So they moved to Xamarin, which added an extra layer of goodness for them because they could develop in C# and they're ASP.NET developers, so that was awesome. And then their customers also started asking for an Xbox app, because when you're talking about video, it's better seen on the big screen. So given that we already had Xamarin, we could easily add on a UWP head that would work on Xbox. And that's where we came in. So our task was to help them create an Xbox app and to create some DevOps for their Xamarin stuff, like Xamarin Test Cloud and Hockey app and a few other things. But what we really did was help them to share more code. And how did we do this? Well, we went with a pattern that we're very, very comfortable with, because we've been doing Windows apps for a long time. And that pattern is MVVM, Model View View Model, where you have the model. That's basically what you get from the API. And then you have the view, so the view, like the window or the page or whatever. And in between you have a view model, something that helps you transform the model to the view, and like just stuff that can be applied to the view. And why does this help you share code? Because suddenly, if you separate out the view model, that means that it's not code that's going to be in the separate views. So you can separate them out from the Android and the iOS and the Windows project and put them in a shared location. And that's what we're helping them do. So what we're going to talk about is a couple of things. So first thing is that we use the model view model pattern with a design time and a runtime view model. And we use this to be able to do design time work and runtime work at the same time, so in parallel. So I do the design, and Peter goes in and does like the coupling to the APIs and everything. And the other thing that we do is we do offline caching to make the apps more responsive. And we'll talk about how we do that too. And finally, we're going to talk about how to apply MVVM to Android and iOS, because Android and iOS natively don't really support the MVVM pattern. And finally, if we have a few minutes at the end, we'll talk about how to customize for Xbox too. So the first thing we do is we go in and sketch up the views. So this is something we do with the customers, and we look at what's going to be on the page. And then we say, so everything that's on a page that's visible, so like current event, there's a current video showing, or lists of video-on-demand events or of live events, live videos, or a list of categories. All of these and a button are things that are visible on screen, so these will be properties in our view models. And these are the only properties our view models have. So we work from the view first and create a view model straight out of the view itself. And then we have commands. So commands is everything that's an activity in the page. So for example, the button click, or when you click on a video and go to the next page or something, or when you click on a category and select it. All of those go to commands, which means that our views can now be completely decoupled from the code. So let's have a look at the code and see how this looks.
Yes, absolutely. So if we look at the solution first, we have 4 products. We have a Xamarin native Android app, we have a Xamarin native iOS app, we have a Windows app, a UWP app, and then we have the portable class level, we have all the shared code. So if we expand this, we can look. Here we have all the models from the backend. We have services so we can access the API. There's a lot of video-related stuff, parsing bit rates, DRM, and stuff like that. This was all done by Librarina. So what we added was the view models.
So everything else was shared already.
Yeah, exactly. So if you look in the view model folders, we have some base classes that we rely on. And then we have the interfaces, so we have defined an interface for each and every view model based on the design sketches we did. And then we have 2 implementations of each view model, one runtime version and one design time version.
I think we should mention that to make this design time version thing working, we have to use a framework. And in our case, we use an MVVM framework that's called MVVM Lite, both because it's light and because it supports design time data.
Yeah.
But how does the design time data look?
Well, first of all, here is the interface for the sketch that Tess had done. So we have the collection of the live events, the video on demand events, and the current event, and here we have all the commands. So here is the runtime version implementation of the view model, but we also have a design time version where we actually can hard code what we want inside the view model. And this really gives us 3 advantages. The first advantage is that Tess can actually do the design with design time data, and we're going to show that soon. The other thing that we get is that we can actually work in parallel. So I can go ahead and code the backend stuff, and Tess can go ahead with the design. And the third advantage is that you can really try out long strings and really test out the interface with the customer.
Yeah, so even in runtime, we can use design time data, as we'll see in a bit.
Yeah. So what we get in Windows with the XAML designer, where we can connect the design time data, you actually get a design time view like this, which is really nice to be able to design. And it's a lot more effective doing the design that way.
So how does it know when to use the design time data and when to use the runtime data?
Yeah. So we use a pattern. We use a view model locator, which uses an IOC container and dependency injection to sort of inject the correct version. So the view model locator has 2 purposes. The first is to expose all the different view models as properties, so you can actually ask for it. And if you look here down in the constructor, we can actually inject the correct version of the view. So if we are in the design time, we actually inject the design time versions of the view models. Otherwise, we inject the runtime versions of the view model.
So can you show how it knows when it's in design time?
Yeah, so we have a little helper function back here. So we use MVVM Lite function. It's a function that actually can return if we are in design mode. We also have a variable so we can force the design time data, and that's very useful if we want to try out the app just with design time data.
Okay, so now we have the design time data, but how do you display it in the page?
Yeah, so we go back to the designer. It's just going to load that. We can actually see here that we do some. So the first thing we do that we assign the view model through the view model locator here to the data context. That's the first thing. So we now associate the view model with the view, and then we can easily data bind properties. This is name and display time is properties of the current event property we had in the view model. If we go down here, we can see we have the show more button command. Show more button. We actually bind that to the command, so actually we don't have to handle a click event or something. We actually have all that code in the view model.
So this works really well in XAML, where even things like buttons have commands that can be data bound. And this works in UWP, it works in VPF, it works in Xamarin Forms, if we use Xamarin Forms. Now we use Xamarin Native, so it's a little bit different. Yeah. But sometimes you have controls that don't have commands.
Yeah. So for instance, here we have the grid view where I actually show all the video on demands. So here we actually have we have a binding here for the VOD events collection, and here you say we want to trigger on the item click and the selection change. We actually wrote wrappers around these events that exposes them as commands, so we can bind them as commands as well.
And if you want to see how this is done, we have a link at the end where we open source the sample that does all this and everything else we're going to talk about.
Exactly. So the last thing I want to show is even for the individual items, we just going to do a peak definition here. We can actually use data binding for them as well. So these are data bound. You can see here, later down we are binding. And these are bound to another view model, which is the event item view model, where we actually model all the properties for a single event.
So how do you populate the view model?
Yeah, so if you look in the runtime implementation of the view model, we see we derive from a base class that we've written, so we actually have to only overload two functions. The first function we want to override is populate. So populate gets called whenever we want to show something and we get a reason for the populate. So in this case we get a populate reason new, which is a new navigation. So in this case we take the chance of actually loading data from an offline storage we have. So we stored the latest result when we last were in this page. In this case we are using JSON files because the data model is very simple, but you can easily use a SQLite or something else instead.
So just to summarize that, so when you get into the page, it goes in, it populates from cache, and then you immediately go out, get it from the web, and store it in the cache again. So it's a two-step process.
Yeah, exactly. So the other function we need to override is the on the request async. So actually here we do a couple of calls to the backend. We sort of transform this data so it suits in our view models, and then we update the collections. And since this is observable collections, we can update only the things that change, so that the user doesn't see a lot of flicker on the screen. The last thing we do here is to save this newly fetched data into the offline cache so we can use it the next time.
So is this only usable if you want to have offline apps?
Yeah, so this is very usable in an offline scenario, but this app is not very useful in an offline scenario because the main usage is showing online videos. But it's still very useful to get a very responsive user interface and not having to wait for the spinner to complete.
Awesome. So does that mean we don't have any code in the code behind?
Well, we have some code in code. I can show you here. So if you look at the code behind here, there's some code related to Xbox and the customization we had to do to the Xbox. But mostly there's a lot of code. If you look in another code behind, you can see that there is actually no code behind.
So the reason why this has the Xbox code in the actual view is because obviously that is not needed in the Android and iOS head. So
no, exactly.
That's why it's only in the UWP one. And we talked about, so with SAML, data binds is super nice.
Yeah.
But what if you don't have SAML? What if you're in iOS or Android?
Well, if you're doing iOS and Android, it depends. If you're using Xamarin Forms to do iOS and Android apps, you actually have data binding supported by the framework. You have XAML, and you actually have support for design time data in Xamarin Forms. So doing this in Xamarin Forms is very, very similar to what we have here. However, these apps are done Xamarin native for a couple of reasons. So here we need some help, and that's why we use MVVM Live, because we need some frameworks to give us data binding, which we didn't have by the operating systems by default. So if we take a look into the main home activity, which is the Android version of this view, we can actually point to a couple of something. So here in the constructor, we actually use the view model locator to assign the view model, which we correlate to what we did in the XAML. The other thing we do is we override setup bindings, where we add code to manually set up these bindings that we did in XAML. And since we don't have data item templates here as well, we need to have a callback function that actually binds each and single item to the data for that.
So this corresponds to whatever we were looking at in the peak window, like this this bind of event item.
Yeah.
And that is really how you can get more code sharing done using MVVM. But we also set out to do an Xbox app.
Yes, we did.
So this is the UWP app, and UWP by default works on Xbox. With the anniversary update, the controls are made so that they will nicely work with the controller and everything. But sorry, is that better? So this is going to not work with a controller, but can you picture yourself sitting in front of an Xbox? So you're probably sitting kind of like a setting like this, probably in your sofa and probably pretty far away from your TV, maybe even in a dark room. So even though you can use this straight as it is on the Xbox, that doesn't necessarily mean that this is a really good experience for the Xbox. So if you have that, a couple of things that you'll end up doing is sorry, there is a super loud echo here, but so a couple of things you want to do is you want to first make the Xbox version darker, because if you use the light version in a room that's going to be dark, it's going to stick out like a beacon. So kind of like if you see a super white PowerPoint in a very dark presentation room. The other thing is that you want to do exactly like you do with PowerPoint, not have death by PowerPoint. You'll end up only showing very little data, reducing the amount, so you take away like the details and everything, and then the data that you do show, you need to show it a bit bigger so you can actually see and read it from 10 feet away. Preferably maybe not more than 3 or 4 rows of data. And then finally, you have a controller in your hand. So with a controller, you're in a different situation than if you can touch the screen. And a couple of things that happen then is if I use the controller and I move left and right, I can only move left and right. I can't move to a random position on the screen, which means that in the UWP app or in the Xamarin app, what we had was we showed a player up top, but in this case, we've decided that we should only show like a snapshot instead. And one of the reasons for this is because if you're scrolling through the list like this, then you'll end up showing a lot of different videos, and you'll end up just seeing a spinner showing the next video. The other thing that you'll end up doing is, what if you're here and you want to pause the video? In order to get up to see the controls, you'll have to move up, and then you'll suddenly move with videos, which is not a very desirable situation. So you have to think about layout and navigation with the Xbox. And what we did in this specific case is that instead of having the video up top, we moved the video to a separate screen, and that's something you see a lot if you look at Xbox apps. But I think one of the cool things is what you see here. I don't need to have an Xbox to do all this testing. I should, of course, test it in an Xbox before release, but you can test a lot of things with a controller attached to your computer, and you get all the interaction, and you can emulate the size of the Xbox and everything like this. So let's move to the resources.
Yeah, so a couple of resources you can look up. Tess talked about our sample code where we have all the base classes and how we do MVM here. Also on Channel 9 there's a very good series on how to do UWP Xbox development. Also there's a lot of good samples on GitHub, UWP Experience for Xbox samples.
And that shows everything, for example, like the how you emulate the Xbox and how you do navigation in a good way.
Yeah. And finally, we did a case study, a write-up, technical write-up on this case. We go into the Xamarin stuff, we go into how we do for the Xbox, and also how we set up a mobile DevOps pipeline for these apps. So you can look at this links and read up on this. So hopefully we've shown you how you really can share code in Xamarin by applying the MVVM pattern. Be very stringent about it.
We'll be around here if you have any questions, but thank you so much.
Thank you.